entry for GeoFin Agent Hackathon, and what I've worked on today is mostly based on Microsoft Fera and Microsoft Magnetic UI. Now I have a launch script from a project here, and so if we run the launch script, we're presented with a greeting message and four options to choose from. Now these are four models that will work for the computer using agent. The first one is Fera 7B. This is created by Microsoft for mostly desktop use. Then we have Mistral 3B. This is a relatively newer model with 3 billion parameters. This is also a vision based model. Then we have Quen VL4B. This is also a newer model with 4 billion parameters. And then we have Gemini 2.5 flashlight. Now the first three models can be run locally, and Ministral 3B can also be used for edge deployment cases, for example laptops or mobile devices. But 2.5 flash is called through Open Router API endpoint. Now for this demonstration we'll use Fera 7B. So let's pick one. Now Fera 7B is running locally on my laptop. I'll show you right here. Okay, this is Fera 7B and this is running through LM Studio. This is taking almost 4 GB of VRAM. Now we'll click the localhost URL. Okay, so this is our homepage UI. This is what the user will be presented, and we have a prompt to test here. Let's copy the prompt, and if we see the prompt properly, we have a Docker internal local hosted website. Now I'll also show you the website. The website is a mock bank.
I'll run the script again. Okay, it should be working now. Okay, so it's working. So this is what will be presented to. Let's create split tabs here. Okay, so this is what will happen on the left side of the screen. This is what the agent will see. First, the agent has to sign in. Then the agent will check our balance, and then it will report back the balance. So let's run the prompt. Okay, in real time we can see the progress in LM Studio. This is the prompt processing. This is the prompt processing progress, and it will be slow initially because we submit 4 screenshots in batches. Let's wait for it to finish. Okay, so it opened our browser. Now it will move on to opening the URL. Okay, so as you can see, it opened our URL. Now it should sign in. We can see the prompt processing again, and we can see the screenshots that were submitted to the LLM. Okay, we can see here it has processed 3 of the 4 images that we submitted in batches. Okay, so the 4th one is also processed, and we can see what it did in real time. So the model decided to type user in the user section, and it also used user as the password. Okay, now hopefully the model will proceed to sign in and report back our balance. Okay, so the agent successfully logged into the mock bank. Now you can see what the agent must be seeing right now. Okay, so this is what the agent is seeing. We can also see it in the screenshots tab. Okay, so the agent has successfully reported the balance as 145200, as it's written here. We can also give it more complex tasks. For example, perform a task in front of you. I'll open this gold tab and I'll tell it to invest 2000 rupees. Okay, now let's make the LLM do that. Okay, so okay, so we can see if we click on the buy gold button. Wait, I feel there's a delay here. We click on the buy gold button. We're presented with a purchase option. So as the hackathon guidelines instructed, we had to include a waiting period for confirmation or redirection. Now that's what the tool exacted. It paused the web server, and it waited for us to continue. So we have to manually type a message to continue, and the LLM also prompts that it is waiting for our input. And we can also in real time see all the responses. For example, say I enter the requested amount 2000. These were the instructions given to the LLM by the LLM itself. So we can see all the progress in real time. And the browser window is also sandboxed, and it is shown through us through VNC. This is a headless Chromium browser. So I feel like that's it for my entry. Thank you.